Question number 18 gives us a rhombus. They tell us that the perimeter is 8 radical 5. They give us the length of one diagonal. So some basic stuff here. We know that rhombuses have 4 congruent sides. So we probably can break up 8 radical 5 into 4 parts in your head, but we've got 8 square roots of 5. They have to be evenly distributed. So 2 square roots of 5 will go with each side length. In other words, whole number can divide into the whole number. So each of the side lengths is 2 radical 5. We can put that into the diagram here. And then we know one of the diagonals is 4 radical 2. Again, the key here, chapter 5, super important because you got to know the diagonals of rhombuses are going to bisect each other, and you have to know that they're perpendicular to each other. Otherwise, you got nothing in this problem. So that's the big giveaway here. You get 4 congruent right triangles, one of the really big ideas that we hammered in chapter 5. So anyway, we don't know which diagonal is the long one and which one's the short one. It doesn't really matter. But we've got to take that 4 radical 2 and we've got to break it up into 2 parts. So again, 4 radical 2 divided by 2. 2 goes into 4 twice. You can't divide a whole number into a radical, so 2 radical 2. And again, that should make sense, right? I've got 2 square roots of 2 here, 2 square roots of 2 there, adds up to a total of 4 square roots of 2. That's how multiplication works. And anyway, at this point, we want to find the length of the other diagonal. So now you have right triangles with 2 out of 3 sides, basically. We can go ahead and just fill this into the Pythagorean theorem. So we'll take one of those right triangles. We've got side lengths of 2 radical 5, 2 radical 2, and we're looking for that other side length there. And so we're going to look at that and put all that in the Pythagorean theorem. Pythagorean theorem says the legs squared plus the legs squared is equal to the hypotenuse squared, and I cannot stress it enough. Make sure that you're putting those values in parentheses. We want the entire leg to be squared, not just the radical part, okay? So again, you should not be using a calculator to do this, okay? You blew away your Algebra 1 teachers by being great algebra students. This is Algebra Review. You should know how to square radical at this point. Anyway, long way, of course, is to multiply it by itself. So 2 radical 2 times 2 radical 2. Remember, this is 2 times radical 2. That's 2 times radical 2. Commutative property says you can multiply these in any order you want. So let's multiply the whole ones together and get 4. Let's multiply the radicals together and get radical 4. Of course, radical 4 is the same thing as 2. 4 times 2 is 8, okay? Again, notice the pattern here. What really happened? 2 got squared, we got 4. Radical 2 got squared, we got 2, okay? So again, remembering from Algebra 1, when you have a product, the exponent can apply to both values. Doesn't work for a sum or a difference. You're gonna have to FOIL in that case, but that's not what we have here. So anyway, we've got x squared plus 8 is equal to, then we're gonna square 2 radical 5 on the other side. I'm gonna do this a little faster now. 2 squared is 4. Square root of 5 squared is 5. 4 times 5 is 20, okay? So again, you need to do that by hand, okay? If you put it in a calculator, make sure you've got parentheses. But we need to be able to do simple Algebra 1 by hand, okay? That's what got you in this class. Anyway, solve the equation. Subtract 8 on both sides. You get x squared is equal to 12. Okay, we'll take the square root of both sides. X is the square root of 12. But remember, just like in 3rd grade when you had to simplify a fraction, for the rest of your life, when you have a radical, you have to simplify it for the rest of your life. Breaks down into radical 4 times radical 3, okay? Square root of 4 is 2. 3 doesn't break down, so it breaks down into 2 radical 3. Remember what they ask us to find. They want the length of the diagonal. So we've got a 2 radical 3 there. We've got a 2 radical 3 there. Again, we know from Algebra 1, when you add like terms, 2 radical 3 plus 2 radical 3 gives us a total of 4 square roots of 3. So 4 radical 3 is the length of our missing diagonal.